Okay.
Sir, your mic is muted.
Yes, ma'am. I know. I am on the other. I am on call with sir.
Sir, we can't hear you, sir. Your mic is muted.
Okay, now it's okay.
No. Still, it is not shown. Ma'am, I am in conversation with the sir, actually.
Okay, sir.
Okay. Okay, welcome to all the participants. I was in conversation with our eminent speaker for today's session, this session, and I was actually helping him in sharing his presentation. So I formally welcome all the participants in this session 11 of FDP. And today we have very eminent speaker with us to take the session and what to say about him, because words are not enough to praise about him, and I can say only the things which are not in his profile, that he is a very humble, very charming, very loving guy whom I ever met, and I must say that I must thanks to the sir for accepting my invitation and giving us this opportunity to interact with him on this platform. Now, I would take this opportunity to kindly request Dr. Ramesh sir to kindly introduce our eminent speaker to the audience. So, over to Ramesh sir.
Thank you, Arvind sir. It's been an immense pleasure for me to introduce such an illustrious speaker, Dr. R. Ananda Raja, on the behalf of Department of Biotechnology, Noida Institute of Engineering and Technology. Dr. R. Ananda Raja, currently working as a senior scientist in Aquatic Animal and Health and Environment Division at ICAR, Central Institute of Brackish Water Aquaculture, Chennai, Tamil Nadu. He started his career in 2001 as a veterinary assistant surgeon and served in the state government for 5 years in Tamil Nadu State Animal Husbandry Department, performing duties like animal treatment husbandry, management, administrative, and extension activities. He has completed his master's and PhD in the major field of veterinary pathology during 2003 and 2016 respectively. He has joined ICAR CIBA 2007 and have been working in Aquatic Animal Health and Environment Division. He has been contributing in epidemiology, pathobiology, diagnostics, antibiotic residues, and therapeutics of bacterial, viral, and parasitic diseases affecting fish and shrimp in brackish water aquaculture. He is having a high range of publications with a very good impact factor in national and international journals. He has received best paper awards in different national and international conferences as well. Currently, he has 3 research projects funded by ICAR. Now, I would like to request Dr. Ananda sir to deliver his talk on precision aquaculture, disease diagnosis, and health management. Over to you, sir.
Thank you, sir. Am I audible?
Yes, sir, you're audible. Uh,
The slides are clear.
now you can minimize that window. Yeah, it is clear, sir. It is clear. Thank you, sir.
Is it okay now?
Yes, sir, it is okay.
Okay. So, good afternoon to all. As I introduced, I am Dr. Anand Raja, working as senior scientist in ICR Siba, Chennai, under ICR. My voice is audible?
Yes, sir, you are audible.
Yes, sir.
Okay, fine. Thank you. So it is a great pleasure to talk to you all regarding the precision aquaculture, under which disease diagnosis and health management of aquaculture. See, the precision agriculture and the nanotechnology making agriculture future ready. The topic itself is very impressive, which is designed by your institute, especially your Dr. Arvind. The topic was very interesting, and how best we are going to make our human population and our country to face the future. Under which agriculture means it is a combination of crop cultivation, animal husbandry, and aquaculture, all together called as agriculture, under which the aquaculture also plays a major role. So when we do any agricultural activities, disease is the major impediment which causes the problem to the farmers, not only to the farmers and also to the end users. So how best the disease diagnosis can be made and how it can be managed well by using the modern technologies. So here I am going to make the presentation. I am not an engineering faculty, though I am a biologist. How best the technology which is there available in the engineering can be very well married with the agriculture, and how best it can be addressed to the farmers' benefits. That's how we will proceed. And the presentation will go like, what is the current scenario of the human population, and what is the requirement of the protein for the ever increasing human population, and what are the challenges faced by this supply of food chain, and also what are the challenges faced by the aquaculture, how best it can be addressed by using the precision aquaculture. That's how we will go about. Sometimes it may be odd to the engineering graduates, but still now you see the concept of multidisciplinary concept has come. So everything should come together so that things will work better and the output will be much better than what is available now. See, if you see the human population, the world population as a whole, during 1927, if you see, it started from 2 billion, and it almost, there is an explosive increase of population. The record says on 2012 it has reached up to 7 billion, and it is again estimated to reach to go about, I mean, it is expected to be doubled during 2100. Almost it will be around 16 billions in 2100. Such an explosive increase of population, how we are going to meet out the protein requirements, how we are going to feed this population. You see, the world population percentages wise, if you see, China and India is sharing more, almost 35, 36% of the entire world population. With limited resources and limited land utility, how we are going to feed this population? That is a very big challenge which stands in front of our eyes. And that's how this topic, you see, future ready, how we are going to make our scientific technical know-how future ready to face the, to meet out the requirements of the population. See, the global animal protein supply, in global animal protein supply, if you see the sources of protein, see, proteins are supplied from through different sources. One is through the terrestrial meat, it is almost 41%. Then milk, egg, and aquatic meat. If you see the aquatic meat, at most it is 6% of the entire share. Almost 15.3% of the protein, global animal protein, is supplied from the aquatic meat. So then you can think of what is the important significance of this aquaculture industry itself in providing the protein to the food to the human population. It not only provides the food to the human population, but also to the animal itself, because for animal feed industry, the protein is brought by the aquatic species itself. Then you see global food fish and supply. See, during 1950, the per capita consumption of the human population is almost 6.5 to 7 kg of fish per capita. But it has risen from almost 7 kg to almost 20 kg. It has risen during the 2018. The global data says it has risen from 7 kg to 20 kg. That means per capita human fish consumption is tremendously increased. Even it is not to the standard what we require, but still it has grown. But you see the aquaculture produce is supplied to the human population through two means. One is by capture fisheries. You see, this is one is by capture fisheries, another one is by aquaculture. So capture fisheries, you can see initially during 1970 years back, it was almost good amount was given supplied by capture fisheries. Again, it is growing, but not in steeply growing, because it is because of natural exploitation. The growth is not that much increasing, and also it is not advisable to completely rely on the capture fisheries to avoid the natural exploitation of the natural resources. But aquaculture, if you see, it is almost during 1950, it is almost negligible amount. But now you see it has gone up to very high. Almost it has taken the 50% of the share from the entire aquaculture producers, fish and fisheries producers. That means aquaculture is having major share for supplying the human needs. So such a big industry, how it can be easily addressed with reason, machine learning and artificial intelligence. That's what we need to see. And of course, I'm not an expert, but still by this talk will be an opening talk which gives you to think over it, and you can introduce your technology into the biology, so that it can the technology as well as the agriculture aquaculture can marry together, and the offspring will be better serving the human population. You see the in Indian context, if you see the Indian fish production during 2015-16, it was almost 10 million metric tons, whereas it has gone up to 14.16 million metric tons during 2019 and 20. Similarly, the export value, excluding the Indian domestic consumption, only export value itself, it has gone from 30,500 crores to 46,500 crores during 1920, or a period of 5 years. You see the growth, phenomenal growth in export earning. Then you can see the domestic consumption also. Not only the income comes through the export, but also this industry is feeding our entire human population in the country itself. That domestic consumption we never take into account, but that will be almost more than 40,000 crores. Okay, so you can see the importance of this industry. You see the Indian food fish consumption itself, the pattern itself, all these 5 states are consuming more. If you see Tripura, it tops almost with the almost 30 kg of fish per day per capita, followed by Kerala, Manipur, Odisha, and Assam. You can see that means we are not good fish eaters comparatively. So we need to increase the human consumption and to alleviate the infantile mortality and also to increase the infant health, we need to give more fish. For that, we need to produce more fish. Isn't it? So for increasing the production, we need to have new technologies. See, aquaculture as a whole, almost it was supplying in the whole, in the entire world, it was almost 7% of the fish for human consumption was supplied by the aquaculture during 1974, but it has increased to more than 50% during 2016, and it is projected to supply more than 62% by 2030. India being a second largest fish producing country in the world, we should be the first people to adapt any new technologies which is available. And aquaculture contributes more than 50% of the country's annual fish production. As I said earlier, in the entire global population, in the entire global statistics, aquaculture is almost 50%. In Indian scenario also, it is almost more than 50%, which supplies the fish production. And not only the high supply of fish production, but also it provides the employment to more than 14 million people during 2016-17. Even we have also reported the same. And during 2021, frozen shrimp alone, one species, shrimp alone, it has contributed more than 73% of the export income. Almost 35,000 crores, 36,000 crores is being contributed by the frozen shrimp alone. Then you can imagine the importance of this aquaculture industry. Then if you see the finfish exports during 2018-19, it is almost 700 million US dollars, almost 5,000 crores, which brought to our country through the export earnings. Then you can imagine the importance of this industry. Again, among the aquaculture, it is again classified into different fields: freshwater, brackish water, and marine, and cold water. So many classifications are there, so many partitions are there. Again, in that, the brackish water aquaculture itself is playing major role because it is using the salt water which could not be used for any other purpose, which is converting into protein. You see, brackish water aquaculture means salt water which cannot be used for human consumption, which cannot be used for agriculture, and the area also, land which is coming under the brackish water aquaculture area also, which cannot be used for any agriculture purposes. This area is being utilized for growing the brackish water aquaculture species, and which supplies the maximum production, which brings out the maximum income to our country. For example, you see entire Penis vaname, which is one species which is cultured in our country in an area of more than 1 lakh hectares, with average productivity of 7.1 tons per hectare during 2021. If you see the total seafood exports in our country is almost 11.5 lakh million tons during 2021. It is worth of almost 44,000 crores, 43,717 crores, out of which shrimp contributes around 51.36% in quantity and 74.31% in US dollars. Shrimp, one species alone. Among this, again, Vanami contributes 83%. You can think of importance of this one particular species. Again, this is shrimp side. If you take the finfish farming, it takes off recent years. But while expanding this kind of industry, which leads to again challenges by either by marketing or by diseases, among which disease plays a major role, major impediment for successful aquaculture practices. If you see this graph, you can see 2010-11, it was almost Penis monod. This is comparison of two species. Blue color is Penis monod on one species, and the green color is Penis vanami. The Penis vanami is introduced by our government of India during 2009 into our country because it is not our native species. It is from US. It is introduced into our country during 2009. Then you see the phenomenal growth, the green, how it is going. Almost it has replaced our native species of Penis monodon. Then Penis vanami culture in our country has increased tremendously, and the production has reached up to 8.15 lakh tons during 2021, which only brought the income of export income of around 45,000 crores to our country. You can imagine the weightage of this particular one species. In that case, if we consider at least one more, two more species like this, then imagine our need, how it will be addressed. For such an important industry, I could say it is an industry, the precision is very much essential because now our farmers are very small farmers, small, marginal, large farmers are there, different levels or different varieties of farmers are there across the country. But for small farmers, how the aquaculture practice should be carried out in precise manner to avoid unnecessary loss, economic loss, to diagnose specific diseases in time so that the loss could be avoided, and to manage the aquaculture ponds from the remote location itself, and to reduce the labor costs. So how the precision aquaculture can help? For that, the machine learning and artificial intelligence is going to be the new era which will help our agriculture as well as the aquaculture and also the animal husbandry, which will definitely cut down the cost of production and increases the production by enhanced scientific know-how. So the precision aquaculture, what happens? It combines so many sensors, clouds, and analytics to enable real-time evidence-based decision-making support system (DSS), decision-making support system to optimize the operations. Because you see, in our country, decision-making support system is available, but it is not up to the mark to support our farmers. That's why this is the right time to marry the aquaculture activities with the artificial intelligence so that it can go hand in hand and the offspring will serve the the farming community in better manner. You see, the publications wise, the precision aquaculture, I mean, in agriculture, if you see, the publications from 2010 onwards, it is keep on increasing. That means the agriculture is going towards the precision agriculture. That means using the so many mechanized machines and artificial intelligence. If you see the publications in the aquaculture, it is almost at lower level, but it started picking up during 2011 onwards. It started rising, and 2017 it is very high publications wise. That means there is a scope for using the artificial intelligence in aquaculture and also in disease diagnosis. Disease diagnosis, early diagnosis of disease is important and paramount important to avoid the economic loss as well as the better management practices in aquaculture. All of you can see what is this. So far, we have been talking about shrimp, which brought around 40,000 crores to our export income. This is the one species, our native species, Penis monodon, which was dominating our shrimp industry. And now this is replaced by other exotic species, Penis vanami, for culture. But still, we cannot get rid of this species because being native species, we need to concentrate this also as an alternative species, and also we can have so many alternative species diversification to avoid any monopoly in the industry. For example, there are some other species: Phaneropenis merguensis, Marsupinis japonicus, Penis indicus, and Penis vanami. These are all the shrimp species. Because always we should not depend on only one species. If you depend on one species, then you will be dictated by some other country or some other fellow man. So to avoid that one, we have to have the species diversification. And if you see the finfish, there are so many species. The dominated, very well accepted, international accepted species, latest calcarifer, then Mugil cephalus you might have seen, then this is Etroplus suratensis, then this is Chanos. These are all the major species. Again, we are adding new more species into this system, and these species are added with hatchery operations and also with brood system, nursery rearing, brood system, marketing, all entire package is being developed in our institute. But in each level, we can have the interference of artificial intelligence from starting from the hatchery, nursery, then growth system and marketing, so that the artificial intelligence can help the farmers, can help the entrepreneurs to perform better and to increase the production. Then again, if you see the crabs, these are all the two species which rules the entire world. And this is being maximum, these species are being exported to other countries from India, which fetches the good price to our farmers. Then these species are cultured in different types. You can see this is a pond culture, shrimp pond culture. Then you can see this is one kind of tank cultures. This is one kind of hapa culture in pond itself in closed containment. Then this is like cage culture in riverine water or in backwaters. And this is like lake culture. This is one more industry which is ornamental fish. Ornamental fish also taking up nowadays, and this can also be used now. Keeping ornamental tanks in the home has become like prestige. So this also industry also growing and picking up. By these all doing this different types of culture, we need to increase the production. This is harvested Pinus Vanami, and this is harvested grey mullet. So by doing all these different types of cultures, somehow we need to increase the production. Suppose to increase the production to meet out the future requirements. That's how with this kind of new technical, new methods of culture adapted, we need to increase the production. While doing this kind of different cultures, how best the artificial intelligence and also the machine learning, how best it can be fit into it, so that the management, it can start from the management, I mean, can start from the stocking density to the regular feeding, regular monitoring, disease monitoring, and up to the harvesting and the marketing, how it can be intervened in between. That we need to see. So my main focus is on diseases. See, disease. What is disease? Disease. If someone is at his dis-ease, not at his ease, that is called disease. You can see David Moore's disease triangle. There is always the interaction. When we are sitting in the room, we are also always, our system is having interaction with the environment and pathogen. Pathogen is available in the environment. When this interaction is continuously happening, when the pathogen wins or when the environment creates a favorable atmosphere for the pathogen to proliferate and the host immune system is going down, automatically pathogen will take upper hand and the disease happens. So there is an interrelationship between the host, pathogen and the environment. When we are sitting in the room, we are always unknowingly, without our knowledge, our system is having interaction with the environment and the pathogen. Pathogen is there. For example, you see the pandemic, COVID-19 pandemic. The COVID-19 is there everywhere now. But thing is, how our immune system works against it, how the environment is unfavorable to the pathogen, then only we are healthy, hale and healthy. Again, if you see the factors which favors the outbreak of any disease, that means high stocking density. that is stocking density, number of animals within a particular unit area. Like for example, in a classroom, suppose 10 people are there. Okay, they feel happy. Without fan also, they can attend the class. But if the number of people are more, then suppose if the number of people are 50, okay, with the fan they can perform well. One fan. If the number of people are 100, then two, three fans or AC, depending upon the situation. So that means to make the environment favorable, there is the intervention of engineering field like fan, AC, and other air cooler. Like the engineering field is required to make the atmosphere pleasant for learning. Likewise, for doing the aquaculture, the engineering field also should come into play to make the atmosphere happy and healthy so that the production will be increased. Then poor water and soil quality, inadequate aeration, because aeration is required, dissolved oxygen is required for getting the successful growth culture. So inadequate aeration, the aeration can be assessed by using the machines, and which can again linked to the mobile phone. When the aeration drops down below the 5 DO, dissolved oxygen level is going below the 3 or 4, immediately SMS can reach the farmer, so that farmer will be vigilant and he can come and address to the problem. Or even if it is not going to the farmers, it can sensitize other machine which will run the other aerators, so that dissolved oxygen level will never go down below 5. Likewise, we need to address the issues. Then untreated water exchange, accumulation of uneaten feeds. You see, overfeeding is dangerous than the underfeeding. So we should never feed in excessive. Okay, then feeding regulation should be regulated. How it can be regulated? It can be regulated by machines, by using the robotics or by using the drones, which can be regulated. So for that, again, the engineering field comes into play to get this proper ration for each and every animals which is grown in the pond. Because here the impediment is animals are inside the water. Nobody can see from outside whether the animals are there inside or not. Also, nobody knows. So for that, what we need to fix some certain cameras inside the water, so that which will give you the exact picture whether the animals are there or not. When you are feeding the animals, whether they are taking the feed or not. If the animals are not taking the feed, automatically the feed is getting disintegrated and into the water, and it is spoiling the water quality. Ultimately, it is making the environment favorable for pathogen to take upper hand, and the animal gets diseases. So that should be monitored through the camera, underwater cameras. So that's what, underwater cameras, so that it can be easily monitored by the farmers. And expenditure also can be cut down almost more than 50% of the expenditure can be cut down by using the artificial intelligence. And again, disease diagnosis, histopathology. Histopathology, okay, I'll come later for that. And physical injuries, if there is any injury to one animal, animal welfare, one animal, if there is an injury, then other animals, if those animals are any like cannibalistic in nature, or some predatory animals are there inside, so it can be easily identified by using the machines, and it can be isolated and treated, or else it can be marketed. And the presence of any virulent pathogen in high counts, that means any bacterial load is very high, or any algae load is very high, or any virus is very high, or any parasitic infestations are very high, that can be easily identified by algorithms. Taking the photographs, that should be identified by using algorithm, and it can easily be addressed. But of course, for telling, it looks like very easy, but not that much easy. That's so easy to adapt, bring it into the practical utility. Hence, it needs very good biologists as well as the engineers to work together to bring out the very good change in our industry. See, diseases in aquaculture. If you see, fish feed, almost 50 to 70% of the entire production cost goes to fish feed alone. Then imagine 50 to 70% of the cost goes to fish feed alone. if you are using any machines or drones which can reduce at least 10% of the production cost, 10% of the feed which is being used for animals, then you can imagine how much the production cost can be reduced. Again, global disease and parasite induced impacts costing almost 10 billion US dollars, almost 74,000 crores in the entire world. 74,000 crores is being spent on the or lost because of the global disease caused to the aquaculture, which can be easily identified by using the machines and other things. And the parasite control program alone, if you see the Western countries, they are growing salmon species. In salmon species, 7.5% of the product's total production cost goes for parasite control alone. Then you can imagine the importance of the parasites in controlling importance of the parasites in growing the salmon farming in Western countries. Similar the case with our Indian context also. Parasites plays a major role which can easily be controlled by using the other means, but it needs to be identified without stressing the animals. If you don't handle the animals, you cannot identify the parasite, ectoparasites, external parasites. But by using the machines, you can take the pictures, you can see the biological, their behavioral changes, and also you can see the number of parasites which is there on the attached to the body. Because once the parasites are there in the animals means you will be keep on feeding the animals will be taking the feed happily, but the parasites will suck away the blood. The animal, though they are taking the feed, but they will not grow in good condition, and it will not gain weight. That is a loss to the farmers. If you see the chronology of shrimp pathogen alone, during 1970, it started. It started with the baculoviral mid-gland necrosis virus, and it started moving towards 80s, 90s, 2000, and during 2004, white spot syndrome virus, one virus came. It has caused a devastating loss to the shrimp industry. As of today, we have enterocytosome hepatopenia in our country. Of course, it is not a devastating disease. It is causing the growth retardation. It is there always. It is also one of the parasite which is affecting the shrimp industry, which is there in the system, which will not cause any mortality, but it reduces the growth rate. That means it is dangerous than the acute diseases. If there is, suppose for example, one viral disease, white spot syndrome virus, which causes the sudden mortality. That means if the disease comes, sudden mortality. Okay, fine. Farmer will not lose much. Whereas only he loses the stocking cost and the growth system, and he can treat again, he can go for new crops. But whereas if you see the EHP, enterocytosome hepatopenia, this pathogen, this is dangerous than the acute diseases, which will not cause any mortality. It causes mortality, very slow mortality it causes, very less mortality, but it stays in the animals, it increases the feed consumption, but animals will not grow. That means farmers are losing in many aspects. Farmers are keep on feeding the animals, so feed cost also going, but animals are not growing, so market cost is coming down. That's why these diseases should be addressed. And one more important disease, early mortality syndrome, AHPND. Early mortality syndrome caused by one bacteria, which is reported in many other countries, but so far it is not being reported in our country. That's why it is saving our industry. You see the economic effects. WSSV, as I said, the white spot syndrome virus alone in Asia during 1992, it caused almost $4 to $6 billion US dollars loss. Likewise, so many billions of US dollar loss is there in the entire world. For instance, in India also, we have estimated the loss during 1819 due to enterocytosome hepatopenia alone, almost 4,000 crores lost to our country. Then you see, due to WSSV, white spot syndrome virus alone, the loss is almost 1,756 crores in our country. Again, because of the disease, I am talking about only one species and one industry. And then you can imagine the other species, other industry, entire aquaculture world itself. The total annual employment loss due to the disease is almost 1.65 million man days. It is worth of almost 52 crores. You can see 52 crores in our country per annum. Then overall probability of the infectious disease in the shrimp industry is almost 49%, almost 50% opportunity is there for getting the infectious disease in the industry. And the loss is almost, annual loss is almost 7,500 crores to this industry because of infectious diseases. Then, for example, you see, there is one agency, international agency, which lists the internationally important pathogens. For example, in human side, you can see United Nations are there. In New York, United Nations is there, under which FAO is working in from Rome, Italy, and WHO is working from Geneva, Switzerland. These are all for human pathogens and human welfare. And if you see the OAE, this is another entity, another organization which works for the. This is World Organization for Animal Health. The OAE stands for Office International des Epizooties, which is located in Paris, France, which listed almost 204 pathogens as on today, which including the 10 pathogens from the fish, 7 pathogens from the mollusks, 10 pathogens from the crustaceans, and 3 pathogens from the amphibians. Why is listing these pathogens? Once these pathogens are found in a particular country, they cannot do any export business to the non-affected countries. So their trade comes, the business comes. Suppose, for example, you see fish pathogen. Almost 10 fish pathogens are listed by OAE. There are so many other pathogens, but 10 pathogens are considered to be internationally important in fish. Similarly, for crustacean species like shrimp, 10 pathogens are important, internationally considered as important. Among these 10, 3 pathogens are so far reported in India from fish species. Likewise, in crustaceans also, almost 4 pathogens are reported from India. In that, very important pathogens are white spot syndrome virus, WSSV, and another one is IMNV. Recently, we have reported from our institute, IMNV also, infectious myonecrosis virus, and IHHNV, infectious hypodermal and hematopoietic necrosis virus also is being reported in our country. And if you see, one more disease, acute hepatopancreatic necrosis disease. This is early mortality syndrome. This is caused by bacteria. Because of this one pathogen, entire Western countries, they were not importing any product from the Southeast Asian countries. But our institute, we have worked on this pathogen, and we have conducted national surveillance to identify the presence of this bacteria, particular bacteria, strain of bacteria in our entire shrimp industry. But we could not get even single pathogen which is causing AHPND. So we have proven that this pathogen is not there in our country. Because of our intervention, our country did not get any red signal warning from the export industry. So we are exporting our shrimp to any country because we have reported that this pathogen is not there in our country. That is our great success, which protected our shrimp industry to be viable during the hardship time also. See, as I said, white spot disease. This is caused by DNA virus. Probably this will be like new for you engineering graduates, but still now this is a time to learn across the field. to enrich our knowledge across the field so that it can be useful and your technology can easily come into the aquaculture, and aquaculture knowledge can easily go into the engineering field, and which can take the advantage of engineering field to protect the animals and to increase the viability. See, even for COVID diagnosis, real-time PCR is playing vital role. Even for the shrimp diseases also, we have been using real-time PCR. Real-time PCR comes from engineering field only. Biotechnology gives the knowledge, but who is manufacturing the machines? It is manufactured by engineers. So that's why I'm telling the artificial intelligence should pick up in our country, and it should help the farmers to identify detect the disease well in advance so that unnecessary expenditure can be avoided. Of course, again, this clinical science, transmission and all not required. It is required when we want to intervene in some stages and which can be cut so that the disease spread can be avoided and the animals can be saved easily. You see, this disease causes white spots on the carapace. Then the mortality, you see, these are all the white spots on the exoskeleton. It causes white spots on the carapace, on exoskeleton, and the mortality happens within 7 days. Once the pathogen enters today, on 7th day, entire crop will go. All the animals will be killed because of this pathogen. Again, this white spot disease, how it can be prevented? See, this white spot disease can, that's what, while managing prevention and control, the all the steps should be understood how the disease is entering into the pond. These are all the means by which the disease enters into the pond. How it is entering? Through personal, through birds, through broodstock and seed, water, pond soil, other peanut shrimps, almost 18 species of peanut shrimps, and other Caribbean shrimp species, almost 8 species, other 7 species of crayfish, and 7 species of lobsters, and 38 species of crabs, polychaetes, all other modes. These are all the modes by which the pathogen enters into the pond. So how this can be prevented? So you can see the green color. This is a remedial measures by following the optimal stocking density and optimum feeding frequencies, and by applying the biosecurity measures, by using the SPF, that means specific pathogen free. That means white spot disease means that white spot disease should not be there in the small host larvae which is used for the growth system. So that if you are using these specific pathogen free animals, then automatically virus is not entering into your pond. That how it can be decided specific pathogen free? For that polymerase chain reaction technique, like RT-PCR now they are using for COVID, no? Like that polymerase chain reaction can be used, PCR can be used for testing the seeds which is negative for specific pathogen, so that the animal will not carry any pathogen into the pond. Then water and pond treatment, then less organic load and zero water exchange. By managing the by adapting the zero water exchange technology, we will not allow any other species which is entering into the pond. If those species are not entering the pond, these species are considered to be a carriers. If you don't allow this species to enter into your pond, automatically you are making the pond free of disease. So that's why zero water exchange technology is adapted. By all these means, in all these stages, you can, in each stage, you can apply your machine learning and artificial intelligence, how best it can be adapted and how best it can be managed for getting a successful crop culture. And white spot disease, if you see, prevention and control, how it can be prevented? That's what, as I said previously, it starts from pond preparation to avoid the virus carriers and treating the pond water by using 30 ppm calcium hypochlorite, then using the PCR tested WSO free PLs post larvae or SPF specific pathogen free stocks, and using the strict biosecurity measures and adopting the better management practices BMPs, and avoiding the stressful conditions to the animals. Suppose number of animals stocked in a pond, we don't know how to count the animals. Suppose sometimes lakhs of animals, millions of animals are stocked in the pond. How the millions of animals can be counted? It is not possible. Humanly, it is not possible to count 1 to 1,000,000. So how the artificial intelligence can be used to count, to measure the number of animals in a single stretch? That is what important. Then for water quality management, yeah, sorry, just a minute. Please excuse me, just a minute. I'll come. Yeah, sorry. So avoiding the stressful conditions by limiting the number of animals which is being stocked. For assessing the number of animals in a particular container, so artificial intelligence is of more useful. And for assessing the water quality like pH, DO, dissolved oxygen, and all other parameters, the artificial intelligence again it will work better and help the farmers. Then feeding tail, as I said, by using the drones or by using the robots, the feeding can be done and the pH can be estimated. Then cluster farming. The surrounding farmers should be informed, well informed. If suppose one farmer is getting a disease in his pond, the surrounding farmers should be well informed so that the disease will spreading of the disease to neighboring farmers can be easily controlled. For that, some SMS kind of thing should be there. All farmers should be easily informed so that they will not go to the other farms and pick up the infection. Like our COVID. Now we have to follow the SMS, soap, mask, social distancing. So suppose if someone is positive, like our one app was there, na? Like that app, if someone is positive, automatically other people will know he is positive. So they will not go and get contact with him. So by that way only we can control further spreading. Likewise, here also the farmer should be well informed and the emergency harvest should be done if there is a disease outbreak, and remove the dead animals and bury them away so that the spreading of the disease through the dead animals to the other healthy animals can be avoided. How to identify the dead animals under the water? Because on the ground means it is easy to identify, but under the water it is not possible to identify. So for that, camera, underwater camera will definitely help. And using the chlorination, 50 ppm chlorine for 2 to 3 days, which will kill entire virus population in the pond. And the neighboring farmer should be well informed when we are going to let out our water. Our water should be properly treated with free of virus. Then only farmers water should be let out. When we are leaving the water from our pond, other farmers should be well informed. They should not take those waters for their culture purpose. And the effluent treatment system is very much essential. Effluent treatment system is very much essential before letting out the water to avoid any pathogen entering into the other ponds. As I said previously, this is one more disease, infectious hypodermal and hematopoietic necrosis virus. This is also caused by DNA virus. Of course, it causes run deformity. This deformity in the run and this developmental defect it causes, and the deformity in the rostrum and growth retardation. It is again it causes bubble heads and stunted growth. But this is not much reported in our country, though it is there, but not causing much devastating effect in the shrimp industry in our country. Another disease is infectious myonecrosis, IMNV, which is first reported in Brazil during 2002. This is also one of the important diseases which causes the huge economic loss, almost 100 million US dollars in Brazil itself. This disease recently we have reported in India also. We have reported from Andhra Pradesh. So we are developing some best management practices for this, for control and prevention of this disease. This is caused by RNA virus. Symptoms, if you see, typically there will be distal abdominal segments will be almost tail fan, and this area will become cooked appearance. Though animals are live, this will give you like cooked appearance, this kind of appearance. So that means this also causes the huge economic loss in the shrimp industry. Then you see infectious myonecrosis. You see, this is PCR picture. As I said, polymerase chain reaction picture. Here is molecular weight. This is almost 139 base pairs molecular weight comes, means it is that those DNA samples are positive for IMNV. Then this is the histopathology slides. Histopathology. This is the muscle, skeletal muscle is having some degenerative changes, and this is the lymphoid organ which causes, which is almost necrosis, necrotic areas in the lymphoid organs, and this is the presence of lymphoid tissue in the heart of the affected animals. See, by that's what I was telling you previously, like histopathology. Histopathology means it is like slides we are preparing, but how best it can be quantifiably assessed the damage which is caused by the virus. So quantifying the slide reading, the artificial intelligence is very much essential. Then another bacterial diseases, you can see vibriosis, which causes localized blisters. There are so many species of vibriosis. Vibrio, like Vibrio alginoreticus, Vibrio parahemolyticus, Vibrio harvey, Vibrio other, so many other species which is having the chitinolytic capacity, which can cause the localized blisters, swollen hindgut syndrome, and generalized septicemia. So these are all the bacteria which is available in the pond, isolated from the pond. So this bacterial load also can be easily assessed by using the artificial intelligence. So when the bacterial load goes beyond certain level, then immediately a warning signal can be given to the farmer so that they can easily identify and take the remedial measures without losing the crop. And again, bacterial shell disease, which are like light or dark brown local lesions, and necrosis will be there on the surface of the body, surface of the fish. And the red lug disease, legs will be red in color. You see, you can see red color discoloration in the shrimp. And the black gills, these are all the gill region. It causes black gill in the shrimp. These are all the things which can easily be identified by using the underwater camera, because inside the water we cannot identify what is happening to the animals. So by using the artificial intelligence, these diseases can easily be identified and quantified, how many number of animals are affected inside the water. So accordingly, final decision can be taken whether to treat the animals or to harvest the animals immediately, to make the emergency harvest. These are all the possible by way of doing the, sorry, hello, 1 minute, 1 minute, 1 minute. I am online, just a minute. sorry. So by this way, this disease can be easily identified. Then another acute hepatopancreatic necrosis disease, early mortality syndrome, as I said you earlier. This disease is not at all, this is caused by one strain of Vibrio para.
Sorry for the interruption, sir, but you are not audible. I think that there is some network issue.
Ananda sir, you are muted. I think you need to unmute yourself first. Ananda sir, we are not able to listen to you.
I think there is some network issue, sir.
How automatically it is unmuted? So far, okay, no?
Yes,
Yes,
sir.
sir.
Yes, sir. It's absolutely fine. Just for a while, it went muted.
Okay. Now it's okay, no?
Yes, sir. Yes, sir.
Okay, fine. So you can see, as I said, acute hepatopancreatic necrosis disease. It is also called as early mortality syndrome because it causes mortality in shrimp before 30 days of culture. That's why it is called early mortality syndrome, which is caused by a strain of Vibrio parahemolyticus and Vibrio hampeli and Vibrio ovensi. Major strain is Vibrio parahemolyticus, which is having the per-AB toxins, which is reported in so many Southeast Asian countries like Vietnam, Malaysia, Thailand, Bangladesh, China. So many countries it is being reported since 2009, but it is not reported in our country. We have taken it as a challenge and we have conducted national surveillance. We have collected samples from all over the country in all coastal areas where shrimp culture is being practiced. And we have proven that the particular Vibrio parametric strain is not present in our country by using the polymerase chain reaction screening. Again here, the machine only helped. That means engineers helped. They only designed the polymerase chain reaction, that equipment. So by that way, we have disproved the presence of Vibrio parahemolytic strain in our country, causing AHPND. So by that way, we have saved our shrimp industry, and our export earning did not get affected because again, this involves with the export. If the country says the country is positive for EMS or AHPND, the country which is importing the shrimp products from our country, they will not import. So we cannot export our product to those countries which are negative for AHPND. Since we have proved that we don't have the pathogen, we have exported our all products to all other countries. By that way, we retained our capacity of getting the around 40,000 crores to our export earnings through this shrimp industry alone. You see, this is this is a shrimp which causes this hepatopancreas region. This is becoming dark and it is becoming very smaller. Here you can see the white, pale whiteness and the empty gut of the hepatopancreas. Here you can see this is from the healthy animal, hepatopancreas. This is from the affected animals. How it is shrunken and very small, and this is empty gut is there. Gut is very almost empty. Then again you can see this is the histopathological structures. Histopathology of the hepatopancreas, which is primary organ for AHPND. And you can see the hepatopancreas. This is a normal healthy hepatopancreas. These are all the tubules. But you see, this is the affected hepatopancreas, which is not having the any type of cells. Again, this can easily be identified by using the artificial intelligence, because without seeing to naked eye, stretching our eyes, it can be easily microscope can easily be connected to the artificial intelligence, so that it can easily identify the healthy status of the, it can easily quantify the status of the hepatopancreas by seeing the difference. Then again, as I said in the earlier slides previously, the enterocytosis hepatopenia, this is also parasitic disease. Almost there are so many 187 genera of microsporidians are available in the terrestrial and freshwater and brackish water and marine organisms, comprises almost more than 1,200 species. This is again both intracytoplasmic and intranuclear in nature. First, it was reported from Thailand in 2009 in Penis moradon species. In India also it is reported by our institute during 2016. So EHP, whether EHP is there in the animals or not, by visually inspecting is very difficult. So how it can be easily identified? By seeing the growth performance. So growth performance, how best it can be assessed? It can again, artificial intelligence can come into play here and to assess the growth performance, and by seeing the growth variations, it can easily be interpreted whether EHP is there in the pond or not. Again, it causes growth retardation and white fecal syndrome it causes. The fecal material will be white in color. Based on the presence of white feces on the water column, it can easily be identified by using the modern techniques. It causes severe economic loss. You see, these are all the white feces which is floating on the water. This is again hepatopancreas, which is showing the ATM-like structures which is affected with BHP. Then again, another disease condition called running mortality syndrome, RMS. So this is non-infectious disease, but it causes continuous mortality in the swim industry. Mortality starts after 40 days of culture, and it continues every day. 10 animals like that, it will keep on cause mortality, and it reaches even up to 70% mortality. Once if the running mortality syndrome is diagnosed, then immediately farmers can be easily advised to go for early harvesting to avoid the continuous and persistent loss to the farmers. So to identify this one, we need definitely intervention by the artificial intelligence to identify this kind of mortality which is happening inside the water, so that farmers will not lose. Again, white muscle syndrome. Muscle will be white in color. This is again caused by some kind of protozoan parasites like Amazon and Agmasoma. These are the parasites which is there in the skeletal muscle, which causes the white coloration of the shrimp, which will reduce the marketability of the shrimp. Again, if you see the parasitic infections in brackish-water finfishes, earlier we talked about the shrimp. This is about the shrimp. This is about the finfishes. You can see so many parasites: Arglus, Siamensis, Lernanthropsis muglia, Lernia cyprinaceae, Cymothova species, Lernia cyprinaceae, then Arctolosmis species, then leeches, Zenalnocobdella leeches, then again Arglus quadricetus. Then you can see the Caligus minimus, Caligus, so many stages of Caligus. These are all the many parasites which we have come across. Apart from this, there are lakhs and lakhs of parasites which is there even undiagnosed in the water, which causes the unknown economic loss to the fish industry as well as shrimp industry, which can easily be diagnosed based on the intervention of the artificial intelligence. Again, you can see this Amelodinium oscillatum species which is being isolated from the rabbit fish, which causes again severe economic loss by causing the mortality in the fish. So all these diseases caused by caused by virus, bacteria, parasite, fungi, protozoa, and so many other species of pathogens. So this, how it can be diagnosed? By sampling the certain number of animals. Sampling again can be classified into lethal or non-lethal. And again, the microscopic investigation can be made to diagnose the disease. And a special strain also can be used, like Giemsa, flaxin, calcoflor, like that. As far as HND, hematoxylin using strain also can be used. And molecular diagnostic methods like PCR, real-time PCR, could also be used for diagnosing the diseases. And histopathological techniques can give you a clear-cut idea to identify the specific disease which is the cause of the death, because molecular diagnosis will tell you the mere presence of the pathogen. Suppose, for example, real-time PCR will tell you the mere presence of the pathogen in the organism, in the individual, whereas the histopathology will say the presence of the pathogen inside the cells, which is the main cause for the death. That's why histopathology is very much essential. Then microbiological diagnosis and immunological diagnosis like ELISA and so many other antigen antibody based diagnosis. In all these diagnostics, the machine learning and the artificial intelligence can play a major role. Then, as I said, the prevention and control measures, it starts from as far as shrimp culture is concerned, there is no treatment at all. Only integrated management is the remedy. For that, what it starts from the pond preparation, how the pond should be prepared, how pond should be filled with water, how the water should be taken into it, and how the seed should be selected, and how it should be stocked, and the pond bottom and the water quality management, how the water quality should be managed, pond bottom should be managed. Then you can see even how we are going and checking, how we are risking and going into the pond and checking. This kind of checking, you see, they're just floating on the water, taking the water quality parameters for assessing the water quality parameters. So this can be avoided if the artificial intelligence comes to play, and it can easily get the data and we can interpret by sitting in the lab itself. And the pond bottom and water quality, prophylactics and the treatment, what are the things can be used for treating the disease conditions, and how the immunity can be enhanced by applying some probiotics, immunostimulants, and drugs and antibiotics. Of course, antibiotics usage in aquaculture is banned in our country. And some of the probiotics like yeast, bacillus, Vibrio aeruginolyticus, lactobacillus can be used as immune boosters. And beta glucan, chitin, and VP28 proteins can also be used as immune boosters. So far we have, as I said, the precision aquaculture, how it can be used with existing engineering innovations. The precision aquaculture technology allows farmers to recognize variations in field and to apply variable rate treatments with a much finer degree of precision than earlier possible. Because whatever we have been doing so far, it is not right, it may not be right, which can be precised by using a machine through a machine learning. So the control engineering principle should be applied to the production science, and computer vision should be utilized for making a sensor network and using the robotics and converting in the final data into the decision supporting systems through applications of algorithms and Internet of Things. So remote non-invasive observation and automatic monitoring technology is essential. That means when you are handling the animals, automatically animals are stressed. So without handling the animals, remote non-invasive observations are very much essential, and which can easily acquire the data and without affecting the animals and their behavior and stressing the animals, we can assess the animal growth and behavior and whether the animal is succumb to any disease or not. Then robotics and drone technology can be used with advanced information technologies, which can easily used for feeding and identifying the animals. So now Internet of Things technologies are very much essential for our farmers to have a wireless sensor network and to give them decision support systems. For example, this is a model which just for example I have made. Suppose this is a cage culture. Farmer is doing cage culture. In a cage culture, you can see these are all the cameras which can be fit on the top and also under the water, and here also camera sonar system also can be fitted inside. So the lidar system can easily identify which animal is having a disease or which animal is having the behavioral changes, which can easily identify. This data can easily transmit to the through the wireless mode. It can be transmitted to the mobile or some farmers supporting system, so that farmer can easily take decisions. You see, this is tank system. Suppose the farm is growing in a tank, in a pond. So there also it can be easily applied. Sensor can be applied here. Camera can be applied here. This is the outside camera. This is underwater camera. And when the fish is moving during transport also, here also camera can be attached, and it can easily identify what is the behavior of the fish. What is the, if there is any injuries, if there is any disease, it can easily be identified by this way. Then you see, this is the precision for precision aquaculture. Suppose there is a mortality in the pond, the dead animals will float, but we cannot quantify just by taking and counting. So here also the precision aquaculture can help easily. What is the number of animals which is there inside the pond alive? What is the number of animals, the percentage of mortality in the pond, that can be easily identified. Then suppose algae growth. Algae growth is there. How much algae growth? How it can be easily early diagnosed, and it can easily be prevented from this kind of massive growth. And the water quality parameters check, and also you see water quality parameters floating in the water. So this can be avoided by using the artificial intelligence by fitting some cameras inside the water. So conclusion, aquaculture in a near future would be called as a smart factories. They are factories, protein factories. So fish and shrimp diseases in aquaculture pose a significant threat to nutriment security of the human population. So most severe warning to the economic success of the aquaculture is by disease. It is globally admitted. Not only in aquaculture, in animal husbandry, in crops, even in human population. As of today, we are experiencing like COVID-19. The disease gives the most severe warning to the entire population. So hence, early identification thwart from spreading and lead to victorious aquaculture. So the disease should be identified well in advance. It needs to shift from experience driven to knowledge driven approaches to better optimize the production. We have been, our forefathers were doing some aquaculture, some culture, some agriculture. They were doing by their experience. Now those experience we cannot get rid of it. We have to take those experiences that should be driven towards the knowledge driven approaches. It has to be married with the advanced recent technologies so that the production can easily be increased. Acoustic and optical sensing technology providing feeding control and sizing system solutions, and precision aquaculture with recent technological innovations facilitate aquaculture becoming part of the Internet of Things. So this can easily be married together so that our farming community can be very well supported by the recent technologies. So I take this opportunity to thank Dr. Arvind Kumar for giving me this opportunity, and also the HOD Department of Biotechnology, Noida Institute of Engineering and Technology, Greater Noida, for considering me as a speaker for this platform. And I take this opportunity to thank our director, Dr. KP Jitendran, immediately has given permission to give this talk. And I express my sincere thanks to all delegates and viewers who spent time with me for listening to my talk. I hope this talk will be of useful to the viewers and also to the other listeners in future. Finally, I end with quote, brackish water aquaculture for food, employment and prosperity. Thank you one and all. Thank you so much. If you have any queries, I am ready to answer. Please.
Thank you so much, sir, for such an informative presentation, I must say. And this is the one area of agriculture that everyone wants to listen and love to listen to. And you have rightly emphasized the role of artificial intelligence and other emerging technologies in the field of aquaculture. So, as usual, I must ask participants to put their queries, if any.
Yeah.
So, participants are requested to kindly put their queries here. So, meanwhile, the participants are asking their queries, sir. May I take the liberty to ask you something? Sir, on behalf of participants, I'm taking this liberty to ask a few questions here.
Okay.
Okay, sir, like you emphasized upon the role of artificial intelligence and the other technologies in aquaculture. So, how do you see the progress so far in this field? Like, do we have any like running projects in this line? Or some of the researchers or institutes are still working on applying these artificial intelligence and emerging technologies in aquaculture.
Yeah, there are some recently the DBT has funded for assessing the water quality parameters, which can easily be assessed by using artificial intelligence in the pond, like pH, temperature, dissolved oxygen, like water quality parameters. But still, this field is in infant stage only, as far as aquaculture is concerned. But there is a very good scope for getting fund, and I mean, not only getting fund, a very good scope for applying this intelligence unit into the aquaculture industry. So there is a scope. This will be like opening way for all of you to think over it. And if at all, if anything is needed, we can even collaborate and do kind of disease diagnosis by using the artificial intelligence. That will be of useful. We can
That,
apply some projects and get also, so that not only getting the project, but ultimately the technology should serve the farmers. That is our motto.
yes, sir. At least, yeah, everything should be surface out and should benefit the common person. And
Yes, yes.
yeah. So again, it is a request to the participants to kindly ask your queries if any. So I'm still waiting to get any question from the participant. So till I get it from the participant, I must say thanks to you, sir, for
Yes.
accepting of this invitation and giving such a wonderful presentation here. And there is, I would say that lots and lots of things to learn in this science, and this is just a glimpse, I would say, and it need a whole like complete time to study this thing and understand the concepts deeply. And one who is desiring to shape a career in this, I think they would love to contact you. So, with your permission, I would share your contact details also with the participants.
Yes, fine, fine, fine. You can share them.
Yes,
You can
yes, sir.
feel free to talk to me anytime, no issue. Only
Yes,
thing
sir.
we can think of something which can be done to the farming communities. That is important.
Yes,
That will be a
definitely, sir.
yes, yes.
Yes, definitely, sir. So we are moving towards the end of this session, and for this, I must request Dr. Ramesh sir to kindly conclude the session. Ramesh sir, it is over to you.
Thank you, sir. So thank you so much, sir, for delivering such a tremendous talk and giving us your vital time from your busy schedule to grace this
Thank you so
session.
much. Thank you so much.
And thank you so much to all the participants as well for listening the session so patiently. And at last, I would also like to thank AICTE for making this FDP possible and to have such beautiful session by our illustrious speaker, Dr. Anand sir. And really, sir, we have gained a great knowledge on precision aquaculture as you have told us about white spot disease and its preventions and controls as well. So we have gained a lot of knowledge from your talk, basically. So thank you so much, sir, for delivering it. And we are very much thankful to you that you have shared your knowledge with us. So thank you so much, sir.
Thank you. Thank you so much. Thank you so much. I take this again. I take this opportunity to thank Dr. Arvind Kumar, who has been in our institute for attending one training. Of course, after attending training, probably he got impressed upon and he requested me to give one talk on this topic. I immediately accepted, and our director also has given his consent to proceed. And I wish you all the best.
Thank you, sir.
I take this
Thank you so
opportunity
much.
to thank your HOD also and your
Yes, sure.
college administration also for giving me this opportunity and supporting me. Okay, thank you
Sir,
so much.
on behalf of entire biotech fraternity of Noida Institute of Engineering and Technology, I extend my heartily gratitude to you and lots and lots of thanks to you, sir. Thank you
Thank
so
you
much.
so much. Thank you. Thank you so much.
Thank you.
Okay, thank you. Thank you.
Thank you. Thank you, sir.
Thank you.
Thank you, sir.
Okay, thank you. Thank you, Ramesh.
Thank you, sir. Thank you, sir.
Yeah, thank you. Thank you. Right, right.
Okay. I must request now the participants to kindly join back in the next session at 3 p.m. So kindly join on time and do join us at least 10 minutes in advance. So we will be having another wonderful session in day. Thank you so much for joining us. All the participants are also requested to kindly leave the session. Thank you.
Thank you. Thank you, one and all.
Thank you, sir. Thank you,
Thank
sir.
you.
Thank you so much.